I start, I want to congratulate all of you. We are done with calculus, and despite all the hard circumstances that we are facing now, you are 110% ready for the next step in calculus. We are done, and you did a great job, and your knowledge of calculus and performance is solid and complete. So thank you so much for your great work, and I want you to continue with the same performance till the end of the semester. We are going to start another topic, main topic, which is vectors, and I hope that we finish with the same level that we have finished in calculus. You did a great job. Thank you so much. Okay, so I want to start with vectors now. So vectors. The first thing I want to tell you that there are two types of quantities. Quantities are either scalar or vectors. What is the difference? Scalar quantities are quantities that you can represent it with magnitude only, with a value, with a number only. Number is enough to describe it. To describe it and to understand it completely, you just need a number, like temperature. So when I say it is negative 30, minus 30 degrees, right away you know it's going to be freezing cold, and you know what is a negative 30 degrees looks like. If I say age, like when I say a person is 80 years old, so right away you can say stay home and be safe, right? So those are the scalar quantities. It's enough. You can describe it only by magnitude, by a number. Vectors needs magnitude and direction. Example for this force. It's not enough to say that the force is 5 Newton. 5 Newton, it's okay. I tell the magnitude, how much force I have, but I don't know it is acting in which direction. I have to tell acting north, for example. So now you know that if there is a force with a magnitude of 5 Newton and acting in this direction. Velocity, acceleration, all of those are vectors. Needs magnitude, a number that represents how much of that, and direction to tell in which way it acts. Okay, so this is the first thing I want you to know. Now, geometric representation of vectors. How we represent vectors geometrically. So let's say force has a magnitude of 500 Newton and acting east or acting south, anything. So the first thing, we're gonna choose scale. Let's say 1 centimeter per every 100 Newton. So we are going to draw an arrow. It's acting south, so its head going south, and the length of this should be 5 centimeter because it will represent the 500 Newton. So this is how we represent this force. Okay. If I want to if I want to say the magnitude of the force only, I put it between two vertical lines like this. So this is the magnitude of the force. The magnitude of the force here is 500 Newton, and I don't need direction. This only the magnitude. So if I want to say the magnitude of this force, I put it between two vertical lines as you see here. Okay? That's better. Okay. So now, let's say I want to, so example, represent force F with a magnitude 3 Newton acting south 18 east. So as I told you, we are going to choose a scale. So in here, scale will be 1 centimeter per 1 Newton. So we need to draw an arrow that is 3 centimeter long. Okay. And then we are going to, this is our coordinates, this is east, this is north, this is south, this is west, and we want to represent 3 Newton acting south 18 east. So this is the magnitude and this is the direction. So south 18 east, that means the line we are going to draw, or the force, the vector that represents the force, making 18 degree with the south. So I have to draw an arrow in this direction or in that direction. Which direction I should go? The second letter here tells me where I should go. So I am going to measure 18 degrees towards the second letter, towards east. So the measure of the angle is 18 with the south towards the east. So this is the force with a magnitude of 3 Newton. Okay, so this is how we represent the vector geometrically. Okay. Sometimes I'm going to give you two letters. So vector AB. A will be the tail where the vector starts, and B will be the head of the vector where the arrow is. So let's say I want to represent a vector with a magnitude of 7 east. Okay, so this is the east and this is the west. So I'm going to draw a vector with a length of 7 whatever units, and this will be vector AB, this will be A, and this will be B. And the length here, if it's 7, we can choose 1 centimeter per 1 unit, so it will be 7 centimeter. The tail is the second, and the magnitude is 7. So this is how we represent it if we have two letters, tail and head. Okay, let's say we want to represent vector u, which is having a magnitude of 3 and acting east 15 north. So I need a vector with a length of 3 and the direction is east 15 north. So I go with the east and I measure 15 degrees. So this angle should be 15. Then I draw a vector and it has to be towards the north because the second letter tell me which way, because I can draw 15 this way or that way. It is north, so I have to go this way. And the length should be 3 units. Okay, and this is 50. Alright, so this is how we represent it geometrically. Okay, the second thing, sometimes we represent vectors by knowing the coordinates. I don't know why. The coordinates of its head and tail. So this is another way. Sometimes I tell you point Q is at -1 and 2 and point P is at 3 and 7. Represent vector PQ. So the tail will be at P and the Q will be the head, and find, when I put this between these two lines, what I'm asking, find the magnitude of PQ. You need to find the magnitude. I want to find the length, the magnitude of this vector. Okay, so how can I do this? Alright, this is my coordinate system. I will plot the point -1 and 2. And this is Q. And I will plot the second point at 3 and 7. So probably up there. 3 and 7. I plot the 2 points. Now I will connect the two points like that. Where is the head and where is the tail? P is the tail and Q is the head, so the arrow should go in here. Okay, now I want to find the magnitude of this. The magnitude of this, if we use Pythagorean theorem, this is from here to here is 3, sorry, and from here to here is 1, so this is 4, and from here to here is 7, and from here to here is 2, so this is 5. So I can use Pythagorean theorem and say that the magnitude of vector PQ will equal square root of 3 minus -1 squared plus 7 minus 2 squared, which is square root of 4 squared plus 5 squared, which is the square root of 16 plus 25. That's the square root of 41. Okay, I have to stop and